Hello, everyone. Today, we're diving into the real story behind thorium, a potential game changer in energy. You might have heard claims that thorium is a miracle fuel, zero waste, totally safe, and ready to solve all our problems overnight. But science is about facts, not wishful thinking. Let's separate the myths from reality. One myth is that thorium is being hidden from us by powerful interests. In truth, the challenges are scientific and engineering hurdles, not secret conspiracies. Building new reactors is tough, expensive, and takes years of research. There's no secret plan to stop thorium, just real-world obstacles. Another myth: thorium reactors are impossible. Not true. The molten salt reactor experiment in the 1960s proved thorium reactors can work. The real question is how to make them safe, affordable, and scalable. Some say thorium isn't radioactive. That's false. Thorium is radioactive, just differently than uranium. The waste it produces is also different, and understanding these differences is key. Thorium isn't magic or a secret, it's science. The excitement is real, but so are the challenges. We need to look at the facts, not just the hype. Thorium has potential, but it's not a silver bullet. Let's explore what makes it interesting, and what holds it back. The truth is more fascinating than the myths. Science is about asking questions and digging deeper. So let's get to the bottom of thorium together. Ready to bust some myths? Let's go. The real story is just beginning. Let's explore. So what is thorium? It's a naturally occurring silvery white metal, more common in Earth's crust than uranium. Thorium's symbol is Thi, and it's named after Thor, the Norse god of thunder. For years it was used in things like gas lamps and special glass, but its real value is its radioactivity. Thorium is found in rocks and soil all over the world, especially in India, Australia, and the US. It's abundant, making it a huge untapped energy source. But here's the catch. Thorium isn't directly usable as nuclear fuel. It's fertile, not fissile. It needs a push to start a reaction. Think of thorium as a green log. It won't burn on its own, but with a spark, like uranium, it can ignite. In a reactor, thorium absorbs a neutron and transforms into uranium-233, which is fissile. This uranium-233 can then split, releasing energy and more neutrons, continuing the chain reaction. That's the basic science behind using thorium for power. It's a clever process, but it needs the right technology to work. The potential is huge, but it's not as simple as just switching to thorium. It's about harnessing a natural resource in a new way. The science is real and the possibilities are exciting, but it all starts with understanding what thorium is and what it isn't. It's not a magic rock, but it could be a powerful tool. Let's see how it stacks up against uranium. On to the next round. Time for a head-to-head thorium versus uranium. Uranium-235 is the main fuel in today's reactors, but it's rare and requires expensive enrichment. Thorium-232, on the other hand, is abundant and doesn't need enrichment. Almost all mined thorium is usable. This means less mining and simpler processing, which is better for the environment. When it comes to waste, uranium reactors produce long-lived radioactive byproducts that need secure storage for thousands of years. Thorium reactors generate less waste, and most of it becomes safe in a few hundred years, a much more manageable problem. That's a big advantage for thorium. But remember, thorium still produces radioactive waste. It's just less and shorter lived. Another plus: thorium reactors are less likely to be used for weapons, thanks to the nature of their byproducts. Efficiency is another win for thorium. More energy per kilogram, less fuel needed. But uranium has decades of proven technology and infrastructure. Thorium is still in the experimental stage. So thorium offers big benefits: abundance, efficiency, and safer waste. But it's not a total replacement, just a promising alternative. The real challenge is turning that promise into reality. Both fuels have strengths and weaknesses. The future might need both. Thorium could make nuclear power cleaner and safer. But it's not a magic fix. The science is promising, but the work is just beginning. Let's weigh the pros and cons. What's the real deal with thorium? Let's break down the pros and cons of thorium. Pros: it's abundant, efficient, and produces less long-lived waste. Thorium reactors can be designed with strong safety features. Some even shut down automatically if they overheat. It's harder to use thorium for weapons, making it safer for global security. But there are real challenges. The technology is still in development, and building new reactors is expensive. Thorium needs a starter fuel, like uranium, to get going. Handling the radioactive byproducts is complex and costly. Chemical reprocessing is tough and not yet routine. So, while thorium has big advantages, it also comes with tough engineering and financial hurdles. It's not a perfect solution, but it's a promising one. The future depends on solving these challenges. Why is thorium suddenly in the spotlight? Climate change is driving the search for clean, carbon-free energy. Nuclear power is a strong candidate, and thorium could make it even better. Energy security is another factor. Thorium is found worldwide, offering independence from fossil fuels. Advances in technology are making thorium reactors more feasible than ever. New designs, better materials, and smarter computers are helping solve old problems. Public interest in safe, sustainable energy is pushing governments and companies to invest in thorium research. The world is looking for new solutions, and thorium is part of the conversation. It's not hype, it's about meeting real energy needs. Let's see how these reactors actually work. The most promising thorium reactor design is the molten salt reactor, or MSR. Instead of solid fuel rods, thorium and uranium are dissolved in hot, liquid salt. This molten salt acts as both fuel and coolant, circulating in a loop. Heat from the radioactive salt is transferred to a clean salt loop, which then boils water to spin a turbine and generate electricity. The radioactive material stays safely contained. MSRs operate at normal pressure, reducing the risk of explosions. If there's a problem, a frozen salt plug melts and drains the fuel into a safe tank, stopping the reaction automatically. Waste can be removed and fresh thorium added without shutting down the reactor. This means continuous, efficient operation. The design is safer and potentially more economical. But it's still experimental. No commercial MSRs are running yet. The technology is promising, but needs more testing. That's how thorium could power the future. So is thorium the ultimate energy solution? The honest answer? It's not a magic bullet, but it's a powerful option. The world's energy needs are complex. No single technology will solve everything. Thorium could play a big role alongside solar, wind, and other nuclear options. It addresses key concerns about waste and safety. But it will take years of research, investment, and international cooperation to make thorium reactors practical. Countries like China and India are leading the way with new experiments. The science is real, and the potential is huge. Thorium gives us another tool in the fight for clean, abundant energy. The choice to develop it is up to us. We need to keep asking questions and supporting research. The story of thorium is just beginning. By understanding the science, you can help shape our energy future. Thanks for joining the journey. Stay curious.